Hello friends, welcome to this session on Python scripting in QGIS. My name is Prasun Kumar Gupta and I am with the Indian Institute of Remote Sensing, which is a unit of ISRO located here in Dehradun. So today we are going to talk about how we can ingest or use the Python programming language inside QGIS. And let me tell you, it is the most useful yet uh, uh, most sophisticated functionality available inside QGIS. You need to know a little bit of Python programming or at least uh, any programming language to understand or to fully utilize this functionality. So today we are not going to go into much detail about the Python programming language, rather tell you about what are the different ways you could use Python inside QGIS. There are many ways you could use Python. You could use it to improve your workflows, or let's say you could use it to write more complex models. You could also use it to write things which are not present. Let's say you have a model in your mind, you want to let's say combine certain layers, make some uh, uh, calibration things, or do some sensitivity analysis, or do any kind of a model. You could all write all these things inside Python. Okay, so we are going to do some three small exercises on how to use Python inside QGIS. Let me tell you, this is not exhaustive. There are several other ways you could use Python inside QGIS. Most people, what they do is they use Python, uh, the Python QGIS library. It is called PyQGIS. So uh, there are many websites where you will find many books where you will find details about the PyQGIS library. So you could basically do everything which QGIS does in the Python programming language in a more uh, coding form of a manner, or you could write simple Python lines, few lines here and there inside QGIS to make it more powerful. Okay, so most people either use the PyQGIS library or they build Python based QGIS plugins. So that we are not going to do today. Instead, what we are going to see is all the different ways you could write small Python codes inside QGIS to make it more powerful. Okay, the first one we are going to, so for this exercise, we need QGIS and you need some files. So the files for today is in a folder, in a zip file called Python scripting. Make sure you unzip it before you start the exercise. Try not using these files directly from the zip folder. So for the first one, we'll use a file called Karnataka cities.shp. We are going to use a point layer called Karnataka cities. So let me open QGIS and let me add this file, uh, Karnataka cities.shp, uh, to QGIS, and let us have a look at the uh, attribute table. So if you click on the name of the layer and press F6, function 6 on your keyboard, you will automatically see the um, attribute table. So here you see there are some 5 columns. The second last column, the column with the name NAM, NAM, has the name of the cities. These are basically built up areas or small, it could be a city, it could be a town inside Karnataka. Okay. So what I'm going to do as part of this exercise is try and use Python to extract this name and also extract the location of the points in a single uh, Python code. Okay. So to do that, if you also click on this identify feature tool and then click on any of the points, a pop-up will come which will give information about the feature or the point. So this is a town named Oblapura, and then there are other towns here. Let's say this point here is um, Shirampura and so on. Okay, so there are all these different points. So let me just close these identified toolboxes. And what we are going to do is open the Python console. There is a Python built inside QGIS. So if you go to plugins, you will see the second option says Python console. Okay. Okay. A lot of the text in this video, a lot of things in this video is going to be very small text. So let me try experimenting with the magnifier so as to make the text bigger so that you can uh, view this uh, slightly bigger. Okay. So what I'm going to do is I am going to uh, so this is when I clicked on plugin and Python console, a new box opened for me at the center bottom. It says Python console here, and there is a box which is waiting for my input. So I could write simple Python commands like print hello world, and you will get output in this box here. Okay. So I'm just going to zoom this, and then I'm going to type my commands at the bottom here. So you will see the outputs here. Okay. So I'm still on QGIS, just a magnified version of the bottom, center bottom. So first thing is I need to take the layer that we are going to use. So we are going to use this layer called Karnataka cities. I'm going to say layer is equal to iFace. iFace refers to the current QGIS project, the current uh, uh, layers that are added. Active layer. Okay. So again, all this is very case sensitive. iFace in all small, and then active in small, and layer with an L capital. It has to be written like this. Open and close brackets and press enter. So what it is doing, it is selecting the current active layer, which is in fact Karnataka cities, to my variable called layer. Uh, if you want to repeat the previous line, you can just press the up arrow in your keyboard, and it will again uh, uh, show you the previous line, or you can keep pressing to go back to all the previous, or forward, down arrow to forward, up arrow to previous layers. Okay, so you have to type layer is equal to iFace dot active layer. And what is layer? Just if you type layer now, it says it's a QGIS vector layer, Karnataka cities. So it has already selected that layer and it has put in this. Now, what are the functions? What are the things that I could do with this layer? So there is a very nice function called dir. Uh, if you type dir and within bracket layer, you will see that there are several things that you can do. You can get the metadata, or you can update the fields, you can update geometries, you can do several things. There are hundreds of things that you could do with this specific layer. So what I'm going to do is use this uh, function called get features. Okay. So what I'm going to say is uh, for f in layer dot get features, open and close brackets, colon. So I'm writing a for loop. What I'm doing, I'm going to go through all the points. How many points are there? Just right click on Karnataka cities and click on this option which says show feature count. So it says there are 815 cities and towns in this, or points in this layer. So I'm going to go through all these 815 points and I'm going to select one point at a time. Okay. So I am writing a for loop which helps me loop through all these points. So I'm saying for f in layer dot get features colon, and once you press enter, since you are given a colon, it is waiting for you to write the next line. Now, in Python, you have to give indentations or spaces, unlike in C++ or Java, where you write open and close brackets to specify that this is a block. In Python, you give indentation or spaces. So in QGIS, giving these spaces is sort of your responsibility. You have to make sure that two spaces have been added before typing the second line as the print statement. So I'm going to press with my keyboard two spaces, one and two, and then I'm going to type print F, which is the currently selected feature. Okay. So as soon as I press enter, so you see, so this is a for loop with this printf function inside this for loop. Okay, so that is why the two spaces are very important. That's it. Now I want to run this code. So I just press enter again and you will see it will happen for 814 times. It will select one object and just print this thing here, QGIS feature object at some memory location. Okay, so it is just iterating through each of these points. Not very useful, but this helps me write my second line, which is for each of my points, I want to get the geometry. I want to get the x and y. Okay, so I'm going to repeat the steps again. So as I told you earlier, to repeat the steps, you just press the up arrow two times. So you go up, up, and you have that line for f in layer dot get features. Okay, in case you're not able to get that line, just type it for f. You just click on that Python console and type for f in layer dot get features colon, press enter, then press space two times and then type the next line geom is equal to f dot geometry. Okay, so what have I done? I have created a new variable called geom, which has the geometry for the uh, current selected point. Okay, so it is iterating or looping over all the 800 plus points. So at any instant for the point which has been selected, what is the geometry of that? So that goes in this variable called geom. I press enter. Again, it is waiting. Do I want to do something else in the for loop? Yes, I want to print this geometry. So I press space two times again, one, two, and then I say print this geometry, but don't just print it like this uh, gibberish. I want to rather see it like a point, x and y values. So print it as point. Open and close bracket for the print, and then press enter two times. Wow. So now what I am seeing all the X and Ys of all the 814 points in my Karnataka underscore cities dot shp layer. Okay. Very nice. But can I also see the name of the city and its location together? Maybe you could use it for something else. Let's say you have points for all your dug wells, or maybe you have points for all your lakes, reservoirs, water bodies, and you want to just print that, put it in a text file. You want the name of the dug well, of the village name, which is there in the attribute table. We saw in the attribute table the name of the towns is there. So I just want the name and its location like a text file. So how can I do it through Python? So, first, let us see how we can get the name out, and then we will see how we can combine both. Same thing, we need to loop over all the features. So I'll again, using my arrow keys, I'm going up 2 3 times to this line for f in layer dot get features, and then I am going to say 2 times space print f, and within square brackets the name of my column. Okay. Now be careful with colon, square brackets, small brackets, and all that. Print f within square bracket, within single quotes nam, which is the name of the column, which has the name of the cities. Then square bracket close, and then small bracket for print close, and then press enter 2 times. Now what I am printing? I am printing the 814 different town names. Okay. Now I'm going to combine these two together, take the town name and the point, and then print them together. Also, I saw that when I was doing all these printing, I saw that the points have too many decimal places, which are not very useful for me. Maybe I want to restrict to 2 decimal places or 3 or 4 decimal places. That I'll show you how you can restrict your output to certain number of decimal places. Okay. So let's write the code again. Uh, let's write the for loop again. So for f in layer dot get features, get the geometry. So 2 spaces geom is equal to f dot geometry, open and close bracket, enter, space. Now say print. What do you want to print? Give opening quotes type. I want is the name of the city. So open and close curly braces. Okay, careful with the brackets that I am using. I am using middle brackets or curly braces. Then I want to give a comma, and then I want to give the uh, x value, which is the longitude value. So open curly braces, colon dot 3f, close bracket. Why are we writing this? So that whatever number we are going to print, the x coordinate, that will be up to 3 decimal places. If you want till 2 decimal places, write 2 instead of 3. So colon dot 2f. If you want 4 decimal places, then you write colon dot 4f. Okay. Same for my latitude, colon dot 3f, close bracket. So this is what I want to print as output. Name, then my longitude till 3 decimal places, and my latitude till 3 decimal places. Okay. So this is there is a function called format, which helps us do that. So dot format, then within bracket the 3 values, the name, the x, and the y. So f within square bracket nam, that is my first thing. Second is geom dot as point dot x. So x will give me longitude. If I want lat first, then you can put y, comma, geom dot as point dot x. Yeah. So I have to close 3 brackets at the end. One is for the x, one is for the format, and the last is for the print statement. Okay. So there you have it. It's a long line. Print within brackets, then within single quotes, uh, 2 curly braces, 3 sets of open and close curly braces separated by commas. Inside the second and third one, you write colon dot 3f, colon dot 3f. Then followed by dot format, again open bracket, and the three things that will correlate to each of these. So FNAM correlates to the first one, geometry as point Y correlates to the second one, geometry at point X correlates to the third one. Check the brackets and then press enter, and that's it, and then press enter again. So what it is doing now, it is looping through all the points in that layer, finding the attribute nam. So let's say in one feature it is Bandipur, and then the latitude, which is 11.682 north, and longitude, which is 76.638 degrees east. For this, it is doing for all the 800 points. If your layer has 1,000 points, it will still, the same code will work for 1,000 points, 10,000 points, irrespective. Great. Sir, how to, it's a very useful thing. Can we put the same thing in a text file? Why not? Let's write it into a text file. So writing is using it's a file operation. So we have to first open a file in write mode and then write something to the file. So to make sure that everything is working fine, we'll use this built-in method called with. This helps us make sure that in case your file, the output file that you're trying to write, uh, uh, is at a valid location. You have write permission there, there is space there. So this with command takes care of that. So with open, I want to write it at the desktop here, or let's say in my folder. So this is the folder. So I'm going to take the location of the folder. I'm going to, in the Windows box Python scripting, I'm just going to take this path. So I've clicked on this box which says temp Python scripting, and I'm saying copy, control C on my keyboard. And then I go to the Python console in QGIS, and then I'm saying with open within single quotes paste. Okay, before that I have to write here R. Okay, there is a reason behind why we write IR, because the backslash has a different meaning. So to suppress that meaning of backslash, or if you're using Linux, then you don't need to write R, and you can replace these by front slashes. That is also acceptable. I'll just use my standard notation R. So open within open brackets R, then single quotes or double quotes, whichever you want here. See users, username, desktop, temp, Python scripting, slash, what is the name of the file, output file? So I'm going to call it cities.txt. Okay. I can't see it, I'm assuming. So I'll take my mouse here. Yeah. So cities.txt, then I close the quote, then give a comma, and then within quotes I write W. Let me turn off the magnifier for this example. Uh, Within double quotes I write W, and then I close the bracket and then say as file. Okay. So what I'm doing here, I'm basically opening this file on my desktop cities.txt in the write mode. When I open it in the write mode, even if the file is not present physically, it will create that file. And after creating that file, it will sort of give a file pointer in this variable called file. Okay, so this is a user defined variable. You can use fp, xyz, whatever you want. So this variable name file is basically now pointing at the top of a newly created text file, cities.txt. Okay. Now what do we want to write inside it? I need to write whatever we did earlier, the entire thing, go over the uh, go over the points, and then select each point, get the attribute, get the x, get the y, join it together, and then write it to the file. Okay, so I have to write that whole thing again. Notice this, there is a colon here, so it is expecting a line of a set of lines. So you have to give spaces in the middle. Again, you have to be careful with the spaces. I ended up doing some mistakes, so just be careful with the spaces. So start with two spaces and then say for f in layer dot get features open and close bracket colon. Now there is another colon, so it is expecting another set of lines. So there is two indentations required. Okay, so I press enter. Now I have to give two spaces for the previous one and two new spaces. So total four spaces. 1, 2, 3, 4. Geom is equal to f dot geometry open and close brackets. Enter four spaces again. 1, 2, 3, 4. I create a new variable called line, and I say same thing that I was trying to do inside print within single quotes, curly braces, then dot format. Same thing I'll assign to a variable called line. So curly braces, comma, another set of curly braces. Inside the curly braces, colon dot 3f, comma, curly brace open, colon dot 3f, uh, quotes close, dot format. Achha, one thing I have to add here is a identifier called /n. So what this does is, whenever you write a line in the text file, the next line that you write will start at where the previous line ended. So that is a behavior that we don't want. Everything will be written in one line. Okay, so what we want to do is after writing the first line, it should go to the next line. So that, how do you specify? You write /n, \n. So that ensures that every time it writes a line, it enters a new line. /n means new line, okay, or enter in simple language. Uh, Dot format f within square brackets nam square bracket close, comma, geom dot as point within bracket, no, open and close bracket dot y open and close bracket, comma, geom dot as point open and close bracket dot x open and close bracket. So now I have closed my format bracket, and yeah, this should do it. Just checking all my brackets are in place. Oh, see, this nam has to be within single quotes. So open quote and then close quotes. Yeah, that is it. Now press enter. And then last line, 1, 2, 3, 4 spaces, file dot write within bracket line. So till before this line, we have opened a new file. Now we are iterating through the opened layer, Karnataka cities. For each point, I am getting the geometry. And then I'm creating a new variable called line, which has what I want you, which I want to write into the file. So it has the name, it has the X and the Y, a backslash, a new line. So that is ready. Now this line variable has to be ingested into the uh, file. Now this file is being referred to the variable file. Okay. So file dot write within bracket line, and this press enter and press enter again, and then it will print certain numbers. And then if you open, once it is complete, if you open the file folder where you've kept your files, you should see a newly created text file called cities. And if you open that, you will see the same information uh, in a text file format. So now you see the name of the town followed by its latitude and its longitude. The whole thing for 814 different uh, towns. Okay. So same thing, you could do it for any point layer. So the objective of telling you this is you could take simple statements in the Python console, type it together and write as a bigger logic and create some new um, outputs. The next example that I'm going to show you is how we can run processing algorithms via Python. Okay, so uh, these tools that you see in the processing toolbox can also be called inside the Python console. Okay, and these tools are ever growing, and they also give you this easy batch processing mode. Uh, but there are some cases where you need to incorporate a little bit more custom logic in your batch processing. As all the processing algorithms can be run programmatically via Python API, you can run them via the Python console. So these steps will show you how to run this geoprocessing algorithm via Python console to perform custom geoprocessing task. So what are we going to do now? Just let me remove this layer Karnataka cities. We don't want to use it. Let's start a new project. Click on project and then click on new, and then I can discard. So now I have no layers. I have my Python console, which I am going to close for now. And I'm going to add the layers that I am going to use for this example, which is uh, districts of Karnataka. So I have a shapefile called districts.shp. I'm going to drag and drop it here. In QGIS, you see the districts of Karnataka. And then I also have monthly precipitation data in raster format. So let me select all the files and drag and drop them to uh, QGIS. Okay. You can use this button here to collapse all of them like this. So you see 1, 2, 3, 4 up to 12. There are 12 precipitation files. And if I hide them and show, let's say, one of them, uh, I'm just changing some symbology options so that um, so this is my district boundaries, and this is my precipitation layer. Maybe I want to show it with a slightly different coloring scheme. So you see in the month of August, uh, roughly throughout Karnataka, anywhere from 36 mm to 923 mm rainfall takes place at different places. But you see, most of the rainfall is concentrated on the coastal uh, part of Karnataka. So, what I want to do in this exercise is I want to find out how much rainfall happens in a district in each month. Okay, so let's say this is Uttar Kannada. So in Uttara Kannada, what is the rainfall in January, in February, in March, like that till December? I have that as raster layers, but I want to make a graph, or I want them as as scalar values, or in the attribute table. For each district, or for all the districts, it should create columns. So the first column should be January mean rainfall over the entire district, what is the February mean rainfall over the entire district, and so on till December mean for all the districts. To do that, there is a tool existing called zonal statistics. But what does zonal statistics, or let's run zonal statistics for a single layer, and then we can do it for, single precipitation layer, and then we can see how to automate it to do it over all the precipitation layers. So I type zonal in the processing toolbox. The function that, or the tool that we are going to use, is called zonal statistics. Just double click on it. The input layer is districts, and the raster layer I want to take, let's say, the August month 8 precipitation underscore 08, and then I say create the statistic mean. So you can create all sort of statistics, count, sum, mean, max, standard deviation, and all that. I just want to calculate mean. So I select mean in this statistics to calculate, and then I create a temporary layer and click on run. And once it is, algorithm is finished, just click on close. It will create a new output called zonal statistics, which will be the same polygon district layer. But now if you look at the attribute table of this new output layer, you will see a new column has been created called mean. If you click on the name mean 2 times, it will sort it in descending order. You see the first one is Udupi district, which has the highest rainfall over the district. The mean rainfall is more than 1,000 mm. Then Dakshin Kannada, then Uttar Kannada, and so on. So what if I wanted these columns? This is only for June. I want for January, February, March, April, like that till December. I have all of them as raster layers. But do I have to repeat it 12 times, create 12 different files? No. You can automate it using Python. Okay. So let me remove this zonal statistics file for the time being. And what I'm going to do is I am going to open the Python console and try and automate this whole process. So we are going to go to plugins and go to the second option which says Python console. Okay. Now in the Python console, instead of typing the lines here in an interactive way, you can also write bunch of lines in an editor. So in the Python console, the third icon says show editor. Okay. Again, let me turn on the magnifier just to make it a bit more big and visible. So we are going to refer to this icon here called show editor. When you click on it, it will pop up a new box just next to your uh, Python output console, which is named as untitled 0. It doesn't name a file. Once you save it as a file name, it will give that file name here. You can open an existing Python script. You can open it in an external editor if you have. You can save them. You can run it from here. Do other things like copy, paste, comment, uncomment, and so on. Okay. So let me type my commands here. So what I'm going to say is root is equal to QGIS project dot instance dot layer tree root, open and close bracket. Then for root, or for layer in root dot children print layer dot names. Okay. So what I'm doing here, I'm saying in the current QGIS project, there are multiple layers. Can you just tell me what are the layers? So this 3 lines is basically to get the names of the layers. So for each layer in this root, I am going to get the name of it. So once you write these 3 lines, just click on this run button and you will see the output on left side in the console. So I'm going to say run script, and okay, I got an error which says built-in function method has no attribute layer tree root. Okay, so what I missed is In instance, it is a function, so it has to be open and close brackets. So just to emphasize that any small thing can stop your code from working. So just be very careful as to what is the code and what you've typed here. Okay, now let's click on run again, and I get another error. It says names. Oh, so the names, no attribute names. That means I've typed here layer dot names. It is actually layer dot name, not s. Sorry about that. Now, when I click on run, I see my output. So there are 13 layers. First layer name is district.shp, and then the 12 months precipitation data. Okay. So now we are going to expand on this code. And what I'm going to do is I am going to run this again and again and uh, 12 times and get the output and append it to my district layer. Okay. Before I do that, I want to show you uh, one thing called inside processing, there is something called history. Okay. This is a very useful thing. A lot of people don't know about it. Once you run a tool and you want to run the tool again, or you with certain modifications, or you want to see what was run the last time, just click on history and it will show you a box which has like all the tools that you ran in the past, uh, so on. And if you double click on any one of them, it will show you what were the inputs, sorry, what were the parameters given, what was the name of the output file, and all so on. Everything will is saved in the processing history. So what I am interested in, I ran this zonal statistics. What were the parameters given to that? So there are these parameters. Okay, I need this for my program that I'm going to write. So what is the input? What is the input raster? What is the raster band? What is the statistic? What is the output? All these I need. So what I'm going to do is I'm going to copy this from here, Control C on the keyboard, just putting it in a notepad for now, and closing this box. And then we go back to our code and then expand on it. Okay. So we are going to use another Python, built-in Python library called regular expressions. So I am saying import RE, which is basically a Python library for regular expressions. Okay. Again, the code will be the same, layer tree root. Uh, I also need to say that my input layer, that is the layer which I am going to, my districts layer, for which I am going to append, is it has the name districts. So input underscore layer is equal to districts. Or just to be careful, what I'm going to do is I'm going to take the name from here. So this is the name of the layer. Just rename it, or there is an option to rename the layer. Yeah, rename layer. Then copy this. You can like select this and Control C, copy from your keyboard. Then you're sure that your name is not you've not typed it anything else, and then paste it here. Okay, districts. And then what is my output? My output is my result layer. But so there's a logic I'm trying to implement here. The logic is my output is a districts layer only. It is same as the input, just the columns have been appended, right? So the result layer is in the beginning, it is same as the input layer. Okay. Later we will see how we can append for each month, create a new output, and then update that as your result layer. Okay. So the next step is uh, another variable I want called unique field. Unique underscore field, which is basically a unique column in your uh, vector layer. So it could be the name of the district, but just to be sure, there is, hopefully in most states there is no two districts with the same name, but just to be make sure, I have created another column called code, where the census defined districts codes have been written. So 524, 25, 26, so on. These are all unique numbers. So I'm going to use that column code as my unique field. So I'm going to write here within quotes, code in uppercase, close quotes. Then I'm going to iterate over all my layers. Now I need to make sure that I'm only using the layer which is the precipitation layer. Uh, so I'll just say if the name of the layer, if uh, layer dot name starts with, starts with, within capital letters, precipitation, or just PREC. So I will only do this logic, the following logic, only if I am working on the precipitation layer, not for any other layer that may be there in your uh, QGIS session. Okay, if it starts with precipitation, then what do I do? I have to run the zonal statistics algorithm. So the output of the zonal statistics algorithm, if we look at the, if you look at the, if you look at what is required by this zonal statistic function, first it requires the districts.shapefile. Next it requires the precipitation file. Next, third thing it requires is, I'm just going to press end. This is just to explain what is happening, okay? Next, it requires a variable called raster band. So in case your precipitation raster has multiple bands, maybe you can iterate over that also. So there are sometimes, there is one yearly file which has 366 bands, and you want to find out daily mean over a district or monthly mean. So all that also you can do using this, okay? So but I have only one band, so this will be one. Column prefix, so by default it is underscore. I'll show you what. Then statistics, 2 here means mean. 0 is sum, 1 is count, 2 is mean, 3 is minimum, maximum, standard deviation. You saw that list of values. So 2 here refers to the 0, 1, 2, third statistic, which is mean. And then the name of the temporary layer. Okay. So these are the 1, 2, 3, 4, 6. 1, 2, 3, 4, 6 inputs required for the zonal statistics function. Now I'm going to prepare them one by one. So this I have already prepared. Input layer. Input raster we are getting from here. Layer is the raster. Every time 12 times 12 rasters will change. Raster band 1 will remain constant. Statistics 2 will remain constant. What will change is this column prefix. So every time a new zonal statistic is found, what I want to do is sort of take the name of the precipitation layer. It is precipitation uh, underscore 08, which is the month. Okay, so I want to take out that month value. Okay, how to do that? We are going to use that regular expression library. Again, it is a string matching library. Okay, that is available in many languages. We are going to use the Python version. So we are going to find that pattern, 2-number pattern. To do that, there is a set of lines, pattern within two underscores. Within two underscores, there will be a number. There could be many numbers. Okay, that is the logic which this regular expression means. Between two underscores, there could be multiple numbers, no alphanumeric characters. Like it will not select uh, this 1 km. Why? Because it is the logic I have said is it should be first within two underscores, and second it should be only numbers. Slash d refers to a number. Plus means n number of numbers. Okay. So if it is, so that is the pattern I am looking for. So do that pattern matching. So matches, matches, matches is equal to re dot find all. The name of the function is find all uh, within bracket pattern in the layer name. So layer dot name. Okay. So find this pattern in the name of the layer. It could be 12 layers, right? So I'm trying to find that pattern in that. Once the match is there, the prefix that I'm going to attach to my column is matches. The first match, which is 0, I'm going to take the two characters. So -2 colon. Okay, so two characters from the last two characters basically from the match. So wherever it finds two underscores and a number, it gives the numbers back. So that is what I'm doing here. This could be optimized, but let's keep it like this. Okay, so what are the params? Params are same as what we got from. So let's copy this whole thing and change it in the code editor. Params, what are the params? So params are the following. That is a, sorry about this dancing screen. First is the input layer, which is this input layer. Copy. Never write the name of the layer directly. Put it as a variable. Uh, so input is the result layer. Input raster is the layer name. So current layer dot name. Uh, the raster band will be 1. Statistic will be 2. Output will be memory. Now I'm going to generate a temporary raster. So it is a temporary vector. So memory. And this I have to change. Column prefix. This is basically whatever number I got, 01, 02, 03, whatever. Underscore mean. Okay. So prefix plus underscore. Prefix plus underscore. Okay. So whatever prefix I found here, plus underscore. That is what this means. Okay, column prefix plus underscore statistics 2. So now I have everything that I need. I can, yeah, I'll just for sake of uh, understanding, I'm going to put it all under this like this. Yeah, so these are my params. Now let's call the processing. Result is equal to result is equal to why does it bounce off? Okay, let's make it a little smaller so that it stops bouncing. Result is equal to processing dot run within bracket. What is the name of the algorithm, comma, what are the parameters you want to pass? So parameters we have got in this params. What is the name of the algorithm? It is, if you again go back to history and have a look at this, it will say this is the name of the algorithm. Native colon zonal statistics FB. Okay, so The only way to know this name is to run it once. Or there is also another way. If you bring your mouse over this tool, it will say algorithm ID native colon zonal statistics FB. Okay, so let's paste this here. Result is equal to processing.run. Run the zonal statistics using these parameters and get a memory layer. Okay, so what it is doing, it is taking an input and it is running on the 1st January file. It is creating that column. Now I have a new district file in the memory which has a one column. What I am going to do is take this column as the input to the next layer. So when it is doing February, my district file already has 01. It will add the 02 next to it. This will be given to the 03 layer. So like that. So what I'm going to add one more line here is the result layer. The result layer is equal to this result, and within square brackets, because it is a memory layer, you have to write this result within square brackets in capital letters colon. Uh, that's it. Once the whole for if loop is over, the output that you get, we will add it to the project. So QGIS project.instance dot add map layer, whatever output you got, the result layer. Okay, so this is my program. I know it's a bit heavy, but you need a bit of Python and programming experience. Okay, so when you're going to run this, you will see that it uh, takes the district file, it takes all the layers that are open, and uh, it will create district wise mean rainfall and then create an output layer. Okay, so now let us run this code, and it starts running. It will take a fraction of a second, and then once it is done, it will create a new output layer. If you look at the attribute table, you will see that it has created 12 new columns. Uh, 12 new columns, your monthly mean. So January, February, March, April, and so on till 12 months it has created. And for each month, it has created the mean rainfall of the district. So, although it may appear a slightly steep learning in the beginning, but you will see that you can create do a very advanced things, or reduce the manual effort required in repeating the steps over and over again. Okay, quickly we'll do one last thing using Python, which is not in the Python console. Okay, so this time we are not going to do the Python console, but we are going to see the uh, Python, how we can write Python in the function editor of expression box. Okay, so we need a new set of files for this. So we'll click again on new, remove and discard the project. And for this, we are going to use a very commonly available layer called natural earth layer, 10-meter populated places simple. So these are just populated places all over the world. And if you look at the attribute table, it has several columns like the name of the cities and so on. So what I'm going to do is basically write a function sort of a thing, or create a new function. So whenever you like go to the attribute table and you want to select based on an expression, you use certain inbuilt expressions. What if I could create my own function? So there is a function editor. How do you go there? So you open the attribute table, right click, go to open attribute table, and then there is again an option here which says select features using expression. It looks like an epsilon sign or a summation sign. You click on it and you get this box which says select by expression. Okay. Now, here we will go to this second, the by default the tab expression is open. We'll go to the second tab, which is called function editor. In this function editor, we will start a new function. So there is a plus sign here, which creates a new function, and it generates based on a template file. So we click on plus and we give the name UTM underscore zone, UTM underscore zone dot py, and then click on OK. And you will see it has created a new file and some template code is already there. Okay. So what I'm going to do is I'll not go into details of the code again. Rather, I'll share the code with you. Just copy and paste the code given here and replace the existing code. Just copy this code and whatever is the code written, select all, Control A, delete it, and then paste the code that you copied. Okay. Uh, yeah, hopefully then click on save and load functions. As soon as you do that, if you've done some mistake here, it will give an error, or if there is no error, it means everything is fine. Your function is loaded and ready to use. Now, if you go to expression and if you search get UTM zone, you will see there is a custom function. This custom function code we wrote here. Get UTM zone is a custom function that we just wrote. What it does is based on a specific UTM zone. So let's say I want to find out, give me all the cities which are in, let's say 44 North. This has to be within single quotes, 44 capital N. So when you do that, oh, sorry, sorry. When I get UTM zone must be equal to 44N. When you do that, when you say select features and then you look at the map, you see that all these 129 points are lying in that 44 north. If you change this, let's say I say 45 north and click on select features, you look at these points here, and now if I click select features, you will see the points in the adjoining zone 45 north gets selected. Similarly, if I say 33 north and I click on select features, you will see there are these 186 points in Europe and Africa which get selected. So how did we do that? We wrote a custom function in the function editor. Here also you can use Python. So there are many ways you can use Python in QGIS. One last small example I'm going to show in the same data set is, before that, let us deselect these points. So you can click on this option here, deselect features. The last option here is to use a not so well known feature called map tips. Okay, there is a icon here which says show map tips on QGIS. And when you click on that and then you bring your mouse over a point, it shows some information. How do we change that information which comes here? So to do that, you go to the properties of a layer, right click on the layer name, go to properties, and there is an option on the left side which says display. Just click on that. In this, by default, see it has selected name. So whenever your display name is this column called name. So if you look at the attribute table, this column name gets displayed. So when I brought my mouse over this point, it is showing the name of that specific whatever is the attribute. So Bangalore is being displayed. But if I want something else also, so let's say if I want Bangalore along with its UTM zone to be displayed, how do I do that? So you go to properties, you go to properties, you go to display, and then at the bottom you will see a way to write uh, an expression. So you click on that and you say concatenate concat the column name along with comma a pipe, a symbol pipe. So that has to be within single quotes, comma the output from the uh, UTM zone. So get UTM zone function. Open and close bracket again. So you see one output it is showing here, Ajumani for 36 North. If I say, let's say, I don't know what, there are so many other cities here. Mm, some city named Euro. So Euro pipe 16 North and so on. So you can also add another text here which says, along with pipe, also give UTM zone colon. So it will print like this, Euro pipe UTM zone 16N. Okay. Now click OK and then also click on insert here. Okay. Once you insert, you say apply and then OK. Now if you bring your mouse over any point, it says Rajpalyam pipe UTM zone 43 north. If I take my point here, it says uh, Trincomalee UTM zone 44N. If I go to the northeast, I say I see Brahmanpur. If I go here somewhere, I see Aizawl UTM zone 46N and so on. So this is another way you can ingest or use Python in QGIS. So like this, there are many ways. There's also, you can create plugins. You can use the PyQGIS library to do several other things. So that way, you can exploit or enhance the power of QGIS using the Python programming language. For this, you need some basic knowledge of Python. There are many YouTube tutorials where you can learn Python and then try to ingest or to use them in the QGIS software. So that's all for today. Thank you very much.